Mark is controlling this iPad with only his thoughts. This new demo from Synchron represents a major milestone in the field of brain-computer interfaces, called BCI for short. These brain implants enable users to control digital devices with their thoughts. Apple has its very own BCI input protocol announced back in May. This video shows the new Apple accessibility feature being used with a BCI for the first time. Elon Musk-backed BCI company Neuralink, a competitor of Synchron, has also recently shared updates about its progress. So today we'll be comparing these two leading BCI companies, their devices, the implant processes, what stage of development they're in, and the long-term vision for each as stated by company leaders. Let's start with the device itself. Synchron Stentrode is based on pre-existing medical technology called a stent. Stents are inserted into blood vessels to improve blood flow in the case of a blockage or narrowing of the blood vessel. The Stentrode, similarly, is designed to sit within a blood vessel near the brain's motor cortex. From there, the device can pick up signals in the brain representing a user's intent to move and transmit them wirelessly to take the desired action on a user's device. So far, Synchron Stentrode has been implanted into 10 individuals. Neuralink's flagship implant is called Telepathy. Like Synchron Stentrode, it also allows users to control their devices using only their thoughts. A demo shared by Neuralink showed some of its trial participants playing games like Mario Kart and Call of Duty, as well as controlling a robotic arm and a virtual hand. Neuralink says this will someday enable users to fully embody and control humanoid robots with their implants. So far, 7 individuals have been implanted with Neuralink's Telepathy BCI. Right now, Neuralink's Telepathy features 1,000 electrodes or channels implanted into the brain, compared to 16 electrodes or channels in Synchron Stentrode. Next year, Neuralink aims to triple the number of electrodes and implant their first patient with blind sight, an implant designed to be inserted into the visual cortex of the brain to stimulate it and create artificial vision for the blind. When it comes to actually implanting these devices, Synchron has opted for a minimally invasive approach using something already commonly used in the medical field: catheters. These thin, flexible tubes travel through blood vessels and, in the case of the Synchron Stentrode, allow the device to be inserted near the brain's motor cortex without the need for open brain surgery. The main risk of this type of implant is the same as any stent, which is blood clots forming around the mesh wire. Synchron Stentrode users take medicine to reduce that risk, and the risk also decreases over time as cells grow over the mesh and it becomes incorporated into the blood vessel. Neuralink's implant process involves inserting very small threads directly into the brain itself using a surgical robot. Neuralink's latest surgical robot can insert 1 thread every 1.5 seconds, and more threads per implant means more points of communication between the brain and the BCI. That translates to more speed and complexity in reading and writing information, and more resolution in the case of artificial vision. The risks of this type of implant include the threads retracting or moving out of position, thus reducing the number of usable channels through which information can travel to and from the brain. This has reportedly happened in at least one Neuralink patient already. Synchron told CNET its next step is to run a larger study later this year or next year. The company has told me it expects the Stentrode to cost between $50,000 to $100,000, which is comparable with the cost of other implantable medical devices like cardiac pacemakers and cochlear implants. Neuralink is currently in the midst of its clinical trials and announced it received approval to launch trials in Canada, the UK, and the United Arab Emirates. Both companies are currently using their BCI technology to allow people living with paralysis to control digital devices using their thoughts. Synchron's approach leverages pre-existing, proven medical technologies for a minimally invasive implant that can restore a sense of autonomy for users to access their digital world. Neuralink uses a more invasive process using its own surgical robots with the goal of achieving bidirectional communication with the brain, expanding bandwidth and capabilities by adding more threads, and someday perhaps expanding access of Neuralink implants to people without a medical need. It's hard to imagine any other physical structure being more personal, more sensitive, and more sacred to who we are than our brain. That's likely why this type of technology is capable of inspiring so much hope and fear at the same time.
You can get a heart transplant, you can get a kidney transplant, but I don't know anyone who's gotten a brain transplant. So you are your brain.
Synchron's vision is for brain-computer interfaces to become ubiquitous, like the keyboard and the mouse.
We previously interviewed pioneering patient Mark, who was shown controlling an iPad with his thoughts at the start of this video, about what it's like using the Synchron Stentrode with ChatGPT. You can watch that video right here. What do you think about these two companies and their approach to brain implants? Let us know down in the comments, and subscribe to CNET for more stories of man and machine that make you say what the future. I'm your host, Jesse Orrell. Thank you so much for watching.